Okay, so for the Unit 2 exam review, this first problem, in order to find the derivative using the limit process, you have to use this limit definition of a derivative. So the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, there's been a few variations of this. Sometimes they use c. I don't think they use any other ones, but I always just use x because it keeps it in terms of the variable that I started with. One thing that I will highly encourage that you do is think about what this derivative is without the limit process. So if I were to just look at this function and say, what is the derivative of this? The derivative is 2x minus 1. So that's the answer that I'm working towards. So I could even make myself a note. I know that I'm working towards that answer. Then make sure you get there. So this process over here, the limit process, is what you have to use to prove it. All right, so what I'm going to do in this function is plug this in to any place I have a variable. So my function at x plus h means I'm going to put x plus h here minus x plus h there. That's my first piece, this piece right here. Then I'm going to do minus f of x as is. So that's just this function right here. So x squared minus x. And then that's all over h. So don't forget that all over h part because that becomes really important at the end. All right, then I'm going to just work all of this out. So x plus h squared. X plus h squared is x squared plus 2xh plus h squared. So I'm basically foiling that out. If you need to, over on the side, do this, you can, and foil it out. Otherwise, it does end up this every time. So you can remember that. Then I'm going to distribute this minus sign. So minus x minus h. Then I'm going to distribute this minus sign. So negative x squared and plus x. And that's all over h. I forgot my limit. Sorry, guys, I'm going to take a step back for a second. So this equals limit as h approaches 0. Same thing with this one, limit as h approaches 0. Now, on the AP exam, they are super particular about that. If I would have left that off, I would have lost points for that. So make sure that you keep that on there. Okay, so then I'm going to simplify as much as I possibly can. And what you'll notice happen is a big chunk of this will cancel out. So my x squared cancels with this x squared because it's minus. This minus x plus x cancels. Then all I have left is a 2xh plus h squared minus h all over h. Then I'm going to divide everything in here by h because all of those will simplify. So that's the limit as h approaches 2x plus h squared divided by h would just be an h left over minus h divided by h is 1. Then at this point, I can drop off this limit because I'm actually going to plug 0 in for h. So when we did, if you remember back to when we did limits, one of the methods that you could use for limits is direct substitution. So if that works, you can use it. And here it does. If I plug 0 in, that gives me 2x plus 0 minus 1, which is 2x minus 1. And that was the answer that I was working towards. So I know that I'm right, and I've proved it. I've shown all of those steps to prove it. So make sure on the test that you show all of those steps. Okay, then we get into just the short way of doing your derivatives. Now, if you really wanted to, you could use the limit process for every one of these, but that would take a really long time. So instead, we're just going to take our shortcuts. So this first one would be 3x squared, plus that would be 8x minus 3. That would be plus 0, but you don't have to put that on there. The second one, so I would rewrite this as x to the negative third. So remember, sometimes you have to rewrite those functions to begin with and then do the derivative after that. So that will help a little bit. So f prime of x equals, bring down my negative 3, leave x alone, minus 1 from the exponent. So that makes it negative 4. Well, that means overall, my answer is negative. I'm going to put my 3 on top and my x to the 4th on bottom. Number 4, again, I would rewrite this one. So this is really the same thing as x to the 1/3. So that means my derivative is 1/3 x. If I minus 1 from that, I get negative 2/3. So this could get really messy. So I'm going to write it as my 1 is the only thing that should be on the top of this fraction. But on the bottom, I have a 3. And now this is a cube root. So remember, the denominator is your root. And then the numerator is your exponent. So x squared. Now I put it on the bottom because it was negative. So I took care of that by putting that down there. So that's my overall answer. This one is a trick question, number 5 is, and I always put it on here because everybody messes this up. So pi is just a number. It's just 3.14, keeps going, but it's just a number. So when you do the derivative of that, you will get 0. The derivative of any constant is just 0. This one is another kind of a freebie problem. When I bring down my exponent, that gives me 10x to the 4th minus 6x plus 4. The 7 just drops off. And then this one here, we're going to bring in some trig functions, but there's no product rule or chain rule yet. These are pretty straightforward. So y prime, the 6 stays put, times the derivative of cosine is negative sine, minus 2 times the derivative of sine is cosine. So then I would just make that a little bit prettier. I would put the negative up front, so negative 6 sine of x minus 2 cosine of x. Okay. Number 8, this one is definitely a quotient rule. There's not really a way to bring that cosine up and make it any prettier. So I would just use quotient rule and move on from there. So remember, quotient rule was your low, which is cosine, times the derivative of the high, which would be 4x cubed, minus high, which is x to the 4th, times the derivative of the low. The derivative of cosine is negative sine, all over low squared, so cosine squared of x. So then I need to simplify that top part if I can. I'm just going to make it a little prettier. So I'm going to bring up my 4x to the 3rd cosine x. This would become a plus x to the 4th sine x all over cosine squared, and I would stop there. If you wanted to separate these two into 2 separate fractions, you could simplify one of those cosines. So this side would be 4x cubed over cosine x, but this side would have to stay x to the 4th sine x over cosine squared. So because it's not that much simpler, I'm just going to leave it the way that it is. So remember, on the AP exam, free response questions, the further you simplify, the more room there is for error. So I would just stop right here. All right, this one, you have a couple of options on this problem. You could use it as a product rule. So I could say take the derivative of one but not the other, and then plus do the opposite. That's what I'm going to do. The other option is you could multiply this out. I could FOIL it out and have just a real simple function, kind of like these, and then do the derivative of that. So it depends. Do you want to multiply first or multiply second? I'm just going to wait and do it second. I'll do a product rule. I actually think the other way might be faster, so I'll leave that up to you. So product rule for me would be I'm gonna do the derivative of this one first. So that's going to be 6x squared plus 5. And I'm going to take that times this one as is. And then plus, now I'm going to do the opposite. I'm going to leave the other one alone. And I'm going to do the derivative of the second one, which is just 3. So then my job is to multiply all of this out. So I've got to take my 6x squared times my 3x. That's 18x to the third. And then a 6x squared times a minus 4, that'd be minus 24x squared. And then this would be plus 15x minus 20. Then I've got over here, I have a 6x to the third, and I've got a plus 15x. Okay, so then I can combine my like terms. So I've got an 18x to the third and a 6x to the third. That's 24x to the third. Then I have this 24x squared, so minus 24x squared, leave it. Then I've got a 15x and another 15x, that's 30x. And then at the end I have a minus 20. So just make sure you combine your like terms well. One thing I'd be careful with is your exponents, so make sure when you multiply this out that you're careful with your exponents there. Sometimes that's an easy mistake to make. All right, number 10 is a chain rule, so be careful with this one. Anytime you have something kind of inside and then you've got this outside piece, that's your chain rule. So the first thing I'm going to do is bring my 3 down front, leave this inside part exactly as it is, and minus 1 from the exponent. Then I'm going to take that times the derivative of the inside part. So that'd be a 2x. So then to simplify that, I would just say 2x times 3 is 6x, and then I've got an x squared minus a 6 squared. I wouldn't simplify that any further. You'd have to FOIL all of that out. So I think just leaving it like this is fine. So same thing with number 11. You've got a chain rule. So again, I have this outside exponent that I'm going to bring down front. When I do that, I am going to multiply it by that front, that 5, that coefficient. So that gives me 20 times 2 minus x to the third when you minus your 1. And then times the derivative of this inside part, which would be a negative 3x squared. So to simplify that, I'm just going to multiply those kind of outside pieces. So negative 60x squared, and then my 2 minus x cubed to the third is just going to stay. Okay, so that's all for the free response. I'll stop there and do the multiple choice in a separate video.